Okay, hello you guys. I am providing this overview of Activity 1B from the Diffusion Osmosis packet. This is what we've been doing in class Tuesday and Wednesday, September 29th and 30th. So if you've missed class, this video is to catch you up. Okay, so you should have already completed the pre-lab questions and read through the background for this lab, and this would have been on through pages S7. Okay, again, this document is a PDF available on Canvas. So what I'm going to walk you guys through today is procedures for and the information for activity 1B. Okay, so we're going to be working through this. If you haven't already, now is a good time to stop the video and read through the procedure for part 1B. All right, so hopefully you've read through that procedure for part 1B. We are going to be working with agar cubes. These agar cubes have been soaked in, or they have phenolphthalein in them, and they also have been soaked in sodium hydroxide. So the phenolphthalein is an acid indicator, and sodium hydroxide is a very strong base. So if you notice from this table here, the pink to red color indicates that we have a base, and those agar cubes are pink for that reason. Okay, we're going to be working through the procedures here. So using a metric ruler, measure the dimensions of each cube and record the measurements in your lab notebook. So you guys, if you turn the page, you'll see the way that the tables appear, and so you do need to reproduce these tables in your own lab notebook, and I will provide that information for you. I am going to go ahead and measure those 3 cubes, and then I'll place them with vinegar over the top for 10 minutes. So because of the nature of the materials that we're working with today, I am wearing gloves and also goggles to make sure that I do not damage my eyes. Notice we have 3 different cubes. Okay, and I am working on a paper towel just to keep surfaces as clean as possible. For my biggest cube, it should be roughly 3 centimeters by 3 centimeters by 3 centimeters. My video looks like it's not quite straight down. It is actually measuring 2.7 centimeters in that direction and is 2.6 centimeters, 2.7 again. Okay, so 2.7 by 2.7 and 2.7. Okay, so we do have a cube that is 2.7 centimeters cubed. Okay. In all directions. So that is our big one. Our next cube is measuring at 2 centimeters, maybe 1.9 in that direction, and again 2 centimeters. So I'm just going to go ahead and just make sure that it's fairly consistent. It looks like 2 centimeters to 1.9 centimeters in all directions. Okay. This final cube is 1 centimeter by 1 centimeter by 1 centimeter. So they did a pretty good job with that one in the lab. Okay, so hopefully you guys have the measurements down for those. I'm now going to go ahead and place these cubes back into the cup, and I'm going to cover them with distilled white vinegar. Okay. This will sit for 10 minutes, and I'll show you along the way what's happening to these cubes. So I have just covered these cubes so they're fully submerged in white vinegar, and then I'm going to let them sit for 10 minutes. At this time, I'm just going to go ahead and scoot this over, and I'll show you again in a moment what those look like. And in the meantime, I want to talk to you about some of the other stuff that you need to be doing, okay? So at this point, we have recorded the cube size. You can now calculate the surface area, the volume, and the surface area to volume ratio. All of the formulas that you need to complete this work are on the left-hand side of this page, and this page is S9. S9, okay? You can see my copy here is not great, but after 10 minutes, we're going to remove them from the vinegar, and we're going to observe them and measure them once again, okay? And we'll be recording the measurements of the cube in addition to the measurement of what's changing with the cube, okay? And then ultimately be filling out these tables, completing this graph, filling out this table, making some other calculations. Ultimately, when we're done here today, and you have all of these steps through number 11 completed, you need to please then also try these questions, assessment activity 1 questions. Go ahead and try to do part A as well. Just see what you can come up with. And so there are these questions, and this is page S11. All right, do your best on those. I do plan to go through those questions in class on Thursday and Friday. For you guys, I will make another video about what we're doing on Thursday and Friday in class, and you guys can check your answers. One more thing while we're waiting on our cubes, I just wanted to tell you about a few things that are in Canvas this week. You do have this document in Canvas, and it's a review for our exam. Our exam is currently scheduled for October 9th at 10 a.m. Okay, so again, October 9th at 10 a.m. And so that is during the INE time on that October 9th. Some of you will be able to make it then, I think. Others of you maybe not. So we will touch base. Please communicate with me if that does not work for you. Okay? So this review is there. It is nice to have a hard copy, but so I've put the document on Canvas. Print it out if you're able. If you're unable to do that, if there's any way for me to get you a hard copy, I'm more than willing to do that. Okay? Don't forget about deadlines coming up. Your CELS poster, your CELS lab. If you could send me the pictures of questions answered, that'd be great. And you also have a reading guide this week due for Chapter 5, Sections 5.7 through 5.9, or 5.10, excuse me. Since I still am waiting on our cubes, I will do what I did with your rest of your classmates today in class, and just briefly mention to you that this lab is how I cover diffusion and osmosis. Diffusion and osmosis really deals with the movement of molecules from an area of high concentration to an area of low concentration. The terminology in here is terminology, so this is the vocabulary within the lab. You do need to feel comfortable with this vocabulary. So a concentration gradient does refer to things moving from an area of high concentration, okay? So we have a high concentration on this side, and slowly that concentration dwindles out. So we have our high concentration on this side, low concentration on this side, and so this is representing a concentration gradient. Okay? Diffusion is the simple movement, again, of something moving from an area of high concentration to an area of low concentration. This can happen with smells. This can happen with dyes, particularly if you can picture a glass of water, and if you put a drop of dye in it, slowly that dye will diffuse out. Okay? When we're talking about a particular type of diffusion, where molecules are moving, of water is moving, we are referring to osmosis. So osmosis is a special kind of diffusion dealing with water, okay? And the water will move to an area, from an area of high concentration of water, low solute, to an area of lower concentration of water, or high solute, okay? We'll, in the next class period, deal with these terms. Make sure you're reviewing this. When you get to pressure potential, solute potential, and water potential, those terms will be dealt with again more completely in a lab activity next week. Okay, so again, be sure to review the background in this lab packet if you have not already, and we'll be building on that knowledge in the next few class periods. Okay, I want to show you really quick what's happening to our agar cubes as we have them sitting in the vinegar. So you can notice that the edges of the cubes are becoming clear. All right, and I want you to think for a moment what is happening. The pink is a pH indicator. That's what it's called, phenolphthalein. Phenolphthalein turns pink when the solution is basic, and it turns clear when the solution is neutral or acidic. Okay, and so we are seeing that our cubes are actually becoming white along the edges. And what we're seeing is that there is diffusion of the acid, the vinegar, that we put them in, is diffusing into the agar cube over time. Okay? I'm going to go ahead and pause this for a couple minutes, and we'll let this 10 minutes. Okay, we're back. It has been 10 minutes since we have placed the agar cubes into the vinegar solution. So I'm going to go ahead and pull them out. And I'm going to blot them off. Okay. And then we'll go ahead and measure the distance that the vinegar has diffused into the cube. So I have blotted them off. What I am going to do now is I'm going to cut them in half really quick with this knife. It'll enable us to get to see more clearly that actual extent of diffusion. So how far did the vinegar diffuse into each of these cubes? Okay, and so I'm going to go ahead and measure these for you. So for the smallest cube, the extent of diffusion is 0.3 centimeters. For the large cube, we have 0.3 centimeters. And for the middle-sized cube, it is diffused in 0.3 centimeters. Okay? So the distance that the vinegar traveled in each of the cube was the same, 0.3 centimeters for each of the cubes. Okay? So you can go ahead and write that information in your table, and this will be depth of diffusion. You're going to be putting the time that you have let them sit. The time is 10 minutes, and then calculate the rate of diffusion. You're going to graph the rate of diffusion, and if you use your three different cubes on the x-axis and do the rate on the y-axis, then that will give you a visual of how the rate of diffusion varies or does not vary for each cube. Next, you need to calculate the total volume of the cube, which you've already done. And now you're going to calculate the total volume of the undiffused area, and then calculate the extent of diffusion. Okay, this is just a little bit tricky for some students, so I just want to make sure I talk to you about this before we're done for today. Keep in mind that on our first one, so this one was 2.7, okay, that's what we measured it as. And our extent of diffusion was 0.3 on both sides. So if we want to find the volume of the undiffused area, we are going to take that 0.3 from both sides, so 0.6, and subtract it from our original 2.7. And so if in fact I measure the pink area here, it is 2.1. So that's what you'll use for your new measurement for length, width, and height. Just the main thing that students forget to do is take into account the white on both sides. Okay? I believe that's all, and that should get you in a good place for you to finish up the rest of those questions. Please email me if you have any questions. All right, thanks.